All right, section 20.2, the ellipse and the hyperbola. Okay, so we've seen these shapes before. I think, at least I hope so. I'm going to show you a little example here on one of the shapes because it's kind of interesting to me. It always sparked my interest. But let's define what an ellipse is first. Okay, so an ellipse can be thought of as the set of points in a plane such that the sum of the distances of the points from two fixed points is a constant. All right. So what they're talking about here is this. All right. So I drew a little picture here. Here's an ellipse. All right. And here are the 2 points. And the sum of those 2 points is going to be a distance. Okay. Now, the fixed points are called the foci. So that's going to be here. In here, I can, if I wanted to, I can call that C1 and C2. Those are the foci, okay? And the midpoint between the foci is going to be the center, okay? So you can see the center right here at the origin, all right? And most importantly, the standard form of the equation of an ellipse with center h comma k. So here's our standard form. This is our equation right here. So let me give this a little block in, all right? Because it's very important. So the standard form of the equation of an ellipse with the center h comma k is the quantity x minus h squared divided by a squared plus the quantity of y minus k squared divided by b squared equals 1. Okay? Now, sorry. I was a little ahead of myself here. No, that's fine. Yeah, it equals 1. Okay? Now, note that if h comma k, so if h comma k equals 0 comma 0, like in the picture I have below, you will have an ellipse centered at the origin. Okay? Now, within this picture here, let me erase some stuff. Actually, you know what I'm going to do? I'll just draw it again real fast. Okay? So here's my center right there. Okay, now within this picture, okay, the distance from here to there is going to be A, okay? And the distance, give me a second, from the origin up to the top or bottom, well, that's going to be B, okay? Now, like I said, we see ellipses, hopefully, in everywhere we see, a lot of art uses ellipses and stuff like that. But the thing that really gets me really excited about ellipses is how I think about, when we're traveling in space, okay? And what I mean by that is like us, like the Earth, okay? I don't know if you knew this, but the Earth, so if I actually... Let's do this. Let me get out a little blue color, blue for the Earth. And the center, let's make red for the sun. Okay? So we have the sun and we have the Earth. Okay? So we know that the Earth orbits the sun, okay? And it just so happens that it orbits in a elliptical pattern, okay? Now, there were 2 scientists responsible for figuring that out, all right? Tycho I think you spell it with an H, and Kepler, okay? All right, now, here's what's amazing about this, okay? The Earth will go around in its elliptical pattern. And I don't know if you knew this, but the Earth travels around the sun at 63,000 miles per hour, okay? And the Earth spins one whole day. In 24 hours, the spin is 1,000 miles per hour, okay? I mean, to me, it just blows my mind. Okay, that not only are we spinning at 1,000 miles per hour if you're at the equator, okay, you got to be at the equator. So not only are you spinning at the equator at 1,000 miles per hour, but you're also traveling through space at 63,000 miles per hour. Okay, so what I went ahead and did is in Desmos, I went ahead and I kind of typed all this stuff in right here, okay? And I'm going to show you how this works. So earlier I said that we can think of the ellipse as a set of points in a plane such that the sum of the distances of those points from two fixed points is a constant. So right here in red is going to be our Earth. You could see the two foci here in the orange and blue, okay? And as you could see here, if we stay true to that definition and I hit play, that is the Earth traveling around the traveling around the sun. All right, pretty simple. What do you or pretty neat? What do you think? Let's try it again. And that is us all year. Okay, so right now, we are getting to that point of the year where the weather is starting to break. It's getting warmer and everything, which means that the Earth's tilt is actually tilting towards the sun, whereas in the winter we're actually tilting away from the sun. Okay, now I don't want to make this a big astronomy/physics class or anything like that. All right, if you're really interested in this stuff, I would suggest googling some things. I love science and I love math, and you can't talk about science without understanding math, because mathematics is the language of scientists. So that is me geeking out. Let's get back on track here. So we're not gonna get too difficult with this, okay? What we're gonna do is we're just gonna graph. That's it, okay? So let's go ahead, let's graph. And what we're gonna graph right here is x squared over 9 plus y squared over 16 equals 1. All right? Now, just like in the previous section, all right, in section 1, let's go ahead, let's write out the standard form. So this is going to be x minus 0 squared all over 3 squared plus y minus 0 squared all over 4 squared equals 1 squared. And hopefully from here you can see that we have the center at 0, 0. There's my h. There's my k. All right. Now, excuse me. Now we know the distance from the center to the right side, or above the parabola, is going to be 3. Okay. And b is going to be 4. Okay. So what we're going to do here, xy, let's go ahead. 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Okay. And let's go ahead, let's label this. So that's going to be my x-intercept, 3, 0. And I have one in the other direction, negative 3, 0. Okay. Then I will go up 4, 0, and then down negative 4, 0. All right. And all we're doing is just graphing. That's it. So there's my ellipse, as good as it gets. All right. Obviously, you know where I'm going to go. Just to make this look nice and neat, let's go into Desmos. Okay. Let's go back into Desmos. So give myself a new graph here. And let's go ahead and do x squared. Okay, divided by, what was it, 9? Plus y squared divided by 16. Okay, and that equals 1. And as you can see, their ellipse is a lot nicer than my ellipse. Let me see if I can label this. All right, and let's see if we can get a new graph here. There we go. And I didn't go over far enough. Give me 1 second. There we go. That's better. Okay. And we'll put this, like I said, right next to mine, so we can see how awesome Desmos can do it and how bad I can do it. Okay? But that's it in a nutshell. That's the easiest example we're going to be looking at today. All right? Now, if I wanted to get this a little bit more difficult, okay, I could kind of hide some information from you. For example, Let's say we wanted to do this problem. All right, 4x squared plus 16y squared equals 64. Okay, so right now this kind of looks like that we're almost in the form we need. In fact, if you wanted to, you can maybe even make the argument, well, it kind of looks like a circle, and I wouldn't push back. I would say, you know what, it kind of does. However, notice that we have the coefficients out front, and that changes things. Okay, that changes things. If we go back to a circle, remember the general form of a circle looks like this: x minus h squared plus y minus k squared equals r squared. Notice the coefficient out in front, they're ones. And because this coefficient is a 4 and in front of the y squared it's a 16, that changes the game. So what we're going to have to do, okay? So what we're going to have to do is we're going to have to figure out how can we rewrite this as x minus h squared over a squared plus y minus k squared over b squared equals, in this case, 1. Okay? And it's actually not as difficult as you think. What I'm going to do is I'm going to look here at this 64, and I'm going to divide everything by 64. Notice that gives me 1 on the right-hand side, which is what I want. And on the left-hand side, I can go ahead and take, 4 divided by 64, well, that just happens to be 16. And 16 divided by 64, well, that just happens to be 1/4. So let's rewrite as x minus 0 squared all over 4 squared plus y minus 0 squared. Let me write that y nicer. All over 2 squared equals 1. So here we can see that our center is at 0, 0. Okay? A is going to equal 4, and B is going to equal 2. Okay? So let's go ahead, let's graph that. So let's see, A is 4, so 1, 2, 3, 4. 1, 2, 3, 4, and B is 2. 1, 2, 1, 2. So now I'll just place my points and try to draw the ellipse as best I can. Okay? All right. So notice with both examples here, okay? Let me go back all the way up here because I'm gonna highlight it here. Notice the center was at 0, 0 in both examples. Okay? Well, the next problem I'm going to give you, what if it's not? All right? So our third example here, let's graph. X plus 3 squared all over 25 plus y minus 2 squared all over 36 equals 1. Okay? Now this is already in that form that we want. It's already in the form we want. So our center is going to be negative 3 comma 2. Okay? A is going to equal, well, remember 25 is 5 squared. So A is going to equal 5, and B is going to equal 6 because 6 squared equals 36. So let's just go ahead and we're gonna plot this in Desmos because I don't want to mess this up. I want it to look nice and pretty, and then I'll label everything for you. Okay? So let's go back into here. We'll just get rid of this. All right. So parenthesis x plus 3 quantity squared divided by 25 plus, I'll put the parenthesis there, or the division first, parenthesis y minus 2 quantity squared all over, what was it? 36. And that's going to equal 1. All right. And I'm going to label, let's label the center. The center is going to be negative 3, comma, 2. Okay. I'll make this the same color blue. And let's label it. Okay. All right, there we go. So now let's copy this into our notes. Oh, wrong link, or wrong tab. Okay. And one more. There we go. We'll put it right there. Good. Oh, why did it do that? Let's move you over here. I don't know why I did that. That was weird. Let's just get rid of this. All right, so with here we can see that we have our ellipse, okay? All right, we'll just leave it there, whatever. Okay, so here we go. We know A equaled 5 and B equaled 6, okay, from the equation. So if you look here, 1, 2, 3, 4, 5. So I know that is A. And then B, 1, 2, 3, 4, 5, 6. So this distance right here is B. Okay? Now, the last thing we're going to talk about. Oh, there's the A equals 5 and B equals 6. The last thing we're going to talk about here are hyperbolas. Okay? Oh, forgot an R. Hyperbolas. Okay? A hyperbola is a set of points in a plane such that and this is key, the absolute value of the difference of the distances from the two fixed points is constant. Okay? So I'm going to just give you the equations, okay? We're going to center them at 0, 0. So in general, the standard form of the hyperbola with center h comma k is x minus h squared all over a squared. Looks familiar, however, minus, there's the big difference, minus y minus k squared all over b squared equals 1. Okay? Now, you can have this equation, or you can have y minus k quantity squared all over a squared minus x minus h squared all over a squared. Oh, sorry, this was supposed to be b squared. All over a squared equals 1, okay? So, here, order matters. Okay, the order matters, all right? So, let's just go ahead and let's do some examples, okay? So, note, if the center h comma k equals 0 comma 0, then, and then I'm just going to write this, x minus a squared minus y squared minus b squared equals 1 is going to be our parabola centered at the origin. Okay? All right, so example time. X squared minus 16, or I'm sorry, x squared over 16 minus y squared over 25 equals 1. Okay? So, now I'm going to take my time with this example. Okay? I'm not going to rush it. So, this equation So this equation has the form x squared over a squared minus y squared over b squared equals 1. So we know the center is 0, 0, correct? Also, or let's just put and, if you look here, that's 4 squared and 25 is 5 squared. So we know a equals 4 and b equals 5, okay? So what I'm going to do is I'm going to go ahead and I'm going to graph 1, 2, 3, 4. I'm going to graph the a for now. 1, 2, 3, 4. Okay? All right. Now, to help us, to aid in the hyperbola, okay, we must sketch the asymptotes, okay? So when I say we must sketch the asymptotes, you should be thinking to yourself, what does he even mean by these asymptotes, okay? Well, if we were to go back into Desmos, okay, and we were to graph this, I want you to see what happens, all right? So we get x squared over 16 minus y squared all over 25 equals, no, look at the shape. Look at the shape. Okay? Notice that is completely different from anything that we've seen. Okay? So, you know what I'm going to do? Give me 1 second here. I'm going to shrink this down a little bit. Let's go right there. Let's snip this. Oh, I didn't want that. Right there. Don't move. All right, let's pull this into our notes. Okay, so here's what I'm talking about right here. We have what we call these horizontal, nope, I'm wrong again. Diagonal asymptotes. So within this hyperbola, we're going to have a little box, okay? So it's going to look like this. Okay? And to help us, what we're going to find are those diagonal lines right there, those asymptotes, okay? So to help us with this, all right, we create a box with the corners 4, 5, 4, -5, -4, 5, and -4, -5. Okay? In other words, to help us with this, you create this box where you have every single combination. You have every single combination of 4, 5 with including their negatives. Okay? So in my picture up here, I'm gonna get really, really, really specific now. Okay? So let's go ahead. Let's create this box with my corners. All right. So 4, 5. So that's going to be 4. Oh, I need to go up one more. 5. So that's going to be here, over here, down here, and over here. And what I'm going to do is I'm just going to dot this box in, okay? All right. And I'm going to draw in my hyperbola, just like in my Desmos picture, okay? And then last but not least, okay, I'm going to plot in my asymptotes. And there's my hyperbola right there. Okay? So now the question becomes, well, how did I know? How did I know that it opens, like this opens to the right and this opens to the left? How did I know to draw my, I guess you want to call them parabolas, opening left and right? Well, that comes all the way back up here. This opens left and right. And this will open up or down. Okay? So, remember, order matters. And what really matters is, since the x term here, or the x, term here is positive, I know it's going to open left and right. Since that is positive, it's going to open up or down. Okay? So let's look at another example here. Okay, let's look at another example. Now that we kind of see how everything fits together, this should go a little bit more smoothly now. All right, so let's graph 4y squared minus 9x squared equals 36. Okay, so once again, we're going to have to rewrite this. So let's divide everything by 36. That's going to give me y squared over 9 minus x squared over 4 equals 1. Okay? Since y squared over 9 is positive, all right, this will open up and down. Okay? Now let's find our box. So the box will have the points. Now, the points come from here and from here. So remember, this is going to be B. This is going to be A. So B equals 3 and A equals 2. And that's because 9 is 3 squared and 4 is 2 squared. So our box will have the points 2, 3. Negative 2, 3, 2, negative 3, and 2, or negative 2, negative 3. Okay? So let's start drawing all this. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. Okay, so we know our center, 0, 0. Okay? Now what we're going to do is we're going to draw our box in. So we have 2, 3. It's going to be there. Negative 2, 3 is going to be there. Negative 2, negative 3 is going to be down here. And then 2, negative 3 is right there. So let's dot this in. Okay? And I know this opens up. And that distance is 3 because right there. So and if you wanted to, you can put in your asymptotes. I suggest doing it. Okay? And that's it. That's as hard as it gets. We're not going to derive these equations or anything like that. Okay? All we're going to do is just graph them. That's it. Okay? So I hope this helps. All right. Once again, you can always ask me for questions if you have them. All right. Just email me. Let me know. But in terms of the semester, this is it. This is the last thing we're going to be learning. So I just want to say thank you very much for being an awesome class. I hope you enjoyed the video lectures given the circumstances. And if you ever see me out in public, you can always come up to me and say hello. In fact, I would really like that. I hope you have a good summer, and I just hope you and your family both stay safe. So good luck on finals and everything, and good luck in life, and I will see you when I see you. Bye-bye.